Discover the power of Photoshop 4.0 with Photoshop Essentials. Digital artist and professional instructor Katrine Eisman takes you through a wide variety of tips, tricks, and special projects for creating amazing digital imagery. Learn setup procedures for maximum efficiency, selection techniques for precise layering, easy one-step color and density correction, color adjustments and effects with levels and curves, time-saving keyboard shortcuts, and incredible special effects. Invaluable creative tools for getting the most out of Photoshop 4.0. Photoshop Creative Compositing offers professional techniques for creating multidimensional digital imagery. Through step-by-step instruction, Katrine Eisman provides valuable insight to Photoshop's powerful layering capabilities. Master the use of channel and layer masks for seamless image blending. Learn selective matting techniques, clipping group applications, compositing techniques for maximum flexibility, advanced selection tools, and time-saving tips. A wide variety of techniques that will quickly and easily speed your work and add to your creative edge. Plugin Power 1 features the plugin capabilities of Lightwave 3D with Macroform, Particle Storm, and Wave Filter. NewTek's own Brad Peebler shows you how to quickly master the natural modeling qualities of Macroform's rail tools and productivity toolset. Learn to create complex organic models using simple spline shapes. Use precision scaling and alignment tools to speed your modeling productivity. With Particle Storm, learn how to create cascading water, roaring fire, and showers of sparks. See how to control density, gravity, collision, lifespan, and other characteristics to give your animation lifelike qualities with this incisive particle system package. Learn how to selectively apply filters to Lightwave imagery with Wave Filter. Colorize, posterize, blur, color filter effects, and more. Discover Wave Filter's unique mixing board interface that enables you to animate any of these effects over time. Master these powerful plugins with Plugin Power 1. Learn to quickly create light beams, variable density fog, dust, and smoke with Lightwave Steamer, the powerful pixel filter and particle displacement map plugin. This in-depth view of Steamer shows you how to master its powerful controls. Create ray-traced light beams. Add atmospheric simulation with variable density clouds and fog. Discover how to use Steamer with objects to create dust clouds, billowing steam, and animated smoke trails. Learn to master Steamer's attributes and settings for speed and efficiency. Organic modeling and animation takes you through essential steps for creating realistic creature animation. Learn powerful modeling techniques to quickly model your creature from a simple sketch. Digital artist David Lombardi demonstrates modeling techniques for optimum animations. Learn the capabilities of Puppet Master for natural body movement. Add facial expression using multiple morph targets controlled with Lightwave's Morph Gizmo. Then create the walk sequence incorporating Lightwave's inverse kinematics capabilities. Discover how to set up and combine these features for maximum effect and realism. All this and more available now from Desktop Images.
Dear video professional, the elements of this videotape represent the work of creative professionals like yourself. Unauthorized duplication of this tape not only is a federal crime, but also contributes to the destruction of an industry that you helped create. Please do your part by not duplicating this videotape. Thank you.
A special note for Macintosh users. For any functions mentioned using the right mouse button, hold down the Apple key and click the mouse. Are you suffering from unwelcomed house guests? Are flies vomiting on your food? Finding roaches in your shoes? Then get new Bug Off. You try to get rid of them, but sprays don't work. Aerosols make you gag. Only Bug Off employs an exclusive miniaturized weapon system to seek out and eliminate household pests with surgical precision. Bug Off comes complete with sub-miniature projectile laser-assisted technology. that kills bugs on contact. No roach motels here. Pesky ants just can't hide from Bug-Off's maximized environment shielding system. And those annoying flies. They're just no match for Bug-Off's flying insect roaming eliminator. %50 stronger than sprays. So get Bug-Off today!
Hi, my name's Ace Miles, and on this tape we're going to be covering some of the techniques used in the Bug-Off animation that we created. Everything from hierarchical animation to deformations and displacements. I'm operating currently on a 500 megahertz DEC Alpha processor in a digital equipment machine with a PowerStorm graphics accelerator and 128 megabytes of RAM. Let's get started right away. On a previous modeling tape, we covered a little bit about adding detail to some of the spider mech's parts. One of them was a leg. This is one of the leg segments. Obviously, by looking at the animation, you can see that there are multiple segments to each leg. Each of these segments needs to be able to animate by itself. So we couldn't just save the whole entire leg out as one piece. It would only be able to rotate at one joint. So each piece was saved as leg upper, leg mid, leg lower, and then a foot. These were then parented to the body. And this is what we're going to be covering out in layout. We're going to be looking at the relationship between the legs, the body, and each of the segments, and how to animate them. In layout, if I load each piece of the leg, we'll start with the upper, then the mid, then the lower leg, and then the foot. You can see when they come into layout, they're away from the 0 point, and there's a little tiny dot representing the pivot point. Let me move the camera out of the way and the light out of the way and make it a little easier to see. If I highlight the upper leg segment, you can see its pivot point is down here. What does this mean to us? Well, in terms of animation, if I try to rotate this on its bank, you can see it's rotating around the center point or the pivot point. We gave it this pivot point back in Modeler because of where we modeled it. We modeled it away from the 0 point. So when we loaded it into Lightwave layout, the pivot point comes in offset. This is because it was easier to model the whole entire spider as he would be standing on the ground. For example, this will be our arbitrary ground plane, the 0 point on the y-axis, which is where the foot is resting. So I modeled the spider body up off the ground and the legs in position. This causes a slight problem when it comes to the animation, as you could see before with rotation. Each of these pieces will rotate around that center point, and therefore we have to move each piece's center point one at a time into place. We do this with a tool called Move Pivot Point. I'm going to go into the front view, and I can do that by going up to my selector or by hitting one of my keyboard equivalents. And this way, in the front view, I can see exactly where I'm placing it. I'm going to move the pivot point over to where I want the object to be able to rotate. I want to rotate as if it's connected to the lower leg right here at this joint. I'm going to hit the center button once and deselect it so it'll center, and then I will zoom in with the period key just like in Modeler. This way I can make sure that it's exactly centered where I want the pivot point. I'm going to switch to the left view, and I'm going to hit 3 on the keyboard to switch to that, to make sure that it's centered in all my axes. This would be the z-axis. And once again, back to the front to make sure I hadn't moved it improperly. This should rotate now as expected. I'm going to zoom back out and very quickly go through and move the pivot point of each of the others. Now you see, I moved the object. I have one level of undo, which is a nice thing to have, because I forgot to select Move Pivot Point. You're not moving the object, you're just moving the object's pivot point. A very important thing to remember here is that when you are moving a pivot point, or if you're going to need to move a pivot point, it needs to be done before you apply any rotation or scaling to your object. I'm going to go on up the hierarchy and position each pivot point. And one more. Now these should all be in the same plane, so I'm going to hit 3 on the keyboard to go back, and yes, the pivot points are all lined up right where they should be. The next thing to do with the leg will be to tell them how they're going to react with each other. Currently, if I rotate the upper leg, it rotates by itself, and this would be a very difficult thing to actually do animation with. If I rotated this, we all know the joint is supposed to remain connected. I would have to go through each piece and move them into place, and this just would be a nightmare. So instead, I'm going to reset all my rotations. Before I move any of the pieces or rotate any of the pieces, I'm going to have to parent them together. If you look at your body, you can see your upper arm is parented to your shoulder. Your lower arm is parented to your upper arm. What does that mean? It means when I move my upper arm, my lower arm follows along for the ride. This is because in your body they're connected together with bones. Here in Lightwave, we have to simulate this so that when I rotate the upper leg, the lower leg will rotate with it. We're creating a hierarchy. So I'm going to select the mid leg and parent it to the upper leg. I'm going to select the lower leg, hit the parent button, and select the mid leg. One more time, select the foot and parent it to the lower leg. We've now established the parent-child relationship between the objects. What this means now is that I can rotate the upper leg and all the pieces follow. They are inheriting the parent's rotation. If I rotate the middle leg, the lower leg and foot follow for the ride, and so on down the chain. The motion of the lower leg does not affect the upper leg or the mid leg. Moving each piece separately, like we're doing here, is called forward kinemation. Something else that's going to help with this is locking off certain channels of animation. By that I mean either heading, pitch, or bank. By clicking on the buttons, they become activated or deactivated. When the button's not highlighted, I cannot bank my leg. I can change the heading with the heading active. There are certain legs we don't want to have move on the heading. I'll undo the rotation and turn off the heading so that I can't accidentally turn the leg on its heading. Looking in the top view, you can see we wouldn't want this leg to change on its heading. That would be breaking the leg. The upper leg, we do want to move on its heading, but we don't want to have it move on its pitch. So I'm going to undo the rotation and lock off the pitch channel and only activate the heading and the bank. So now, of course, we need to do this with each of the leg segments according to how they're going to need to be rotated. So if I move down the chain to the mid leg, I don't want heading to move, I don't want pitch to move, just the bank. Likewise, with the lower leg, I don't want the heading or the pitch, I just want to be able to bank. And with the foot, the same thing. I only need to be concerned with the banking. If I do need to rotate this on another axis, it's a simple matter of reactivating that axis. I might want the foot to be able to rotate. For now, I'm going to leave it off. So we started by loading in each individual object, moving their pivot points to where they should rotate, and then we parented them together and created our hierarchy, which then lets us animate it much like you would a claymation puppet or a stop-motion armature, moving one piece at a time and keyframing. Now let's take a look at inverse kinematics, where as opposed to being like a claymation animation, moving each piece individually, I'd rather maybe be able to animate more like I have puppet strings, like a marionette puppet, where I pull on one section and the whole entire arm follows along. Let's see how to do that in Lightwave. What I'm going to need to do is sort of add a puppet string, only we're not going to call it a puppet string. It's going to be a goal object. By this, I mean I will be able to say, I want the leg up here, and the whole thing will move. So I'm going to add a goal object, which is nothing more than a null object. I'm going to move the null into position underneath the foot. And you can see that it's under the foot in the top view as well as the front view. I'm going to put it directly underneath the foot. I have auto keyframe adjust and auto keyframe create on right now, so that when I move this over here, it's going to remember where it was at frame 0. The next thing I'm going to do is open the Objects panel and change the name of the null so that it won't get confused with other nulls in the scene. I change the name of the null by saying Save Object, and then I can just type in a new name. I'll type Goal for now. Since this is going to be the goal of this leg, it's going to follow this everywhere the goal moves. To do that, I click on the very end of the chain, which happens to be the foot. I then go to IK Info, or I on the keyboard, which brings up the inverse kinematics options. The next step is to select a goal for that particular object. Of course, right now we know we only have one goal object. It's named goal, making it very easy. I'm going to turn on full-time inverse kinematics, and I'll explain that a little bit later on. I'm now going to select my goal object and go ahead and move it. You can see by just positioning this goal object, the whole entire leg follows. This is the nature of inverse kinematics. The motion is traversing up the hierarchy or up the chain. The next step is to create limitations for the rotation of each of these pieces. If I select the lower leg and hit I on the keyboard to bring up its inverse kinematics options, you can see that I only have the bank activated. It has some numbers for the minimum bank and maximum bank. These are entered either manually by typing them in or with keyboard equivalents. To determine how far it should move, first I have to deselect the full-time inverse kinematics. So I'm going to go back to my foot, hit I on the keyboard, and turn off full-time IK. Or I could just say none for the goal object, and that will just deactivate inverse kinematics entirely. So now moving the goal doesn't have any effect on the leg. This is important because all I need to know is how far this leg should rotate when I move the goal. I can do that by simply rotating with my right mouse button on the bank and then looking at the directions window in the bottom left-hand corner. I'm only interested in the bank, and currently bank is selected. Now, I just created a keyframe for this at 0 because I do have auto key adjust and auto key create on. So for this step, I may want to take that off so that I don't keep creating keyframes. I'm going to go ahead and reset the bank by hitting the reset button and then manually create a keyframe back at 0 for that. It's very easy to forget that you have auto key adjust on, and while you're adjusting your bank limits or your heading limits, all of a sudden realize that you've created a new keyframe at frame 0 for your leg. So I'm going to go back to frame 0 where it's vertical, and I can see that my bank is at 0, 0, 0. I only want my leg to be able to bank about that far, and you can see that that's moving into the positive axis of the bank heading, or bank rotation. So I'd say that's about far enough. I can either write this number down, hit I on the keyboard, and then enter that number for my maximum bank amount, or once again on the keyboard, when it's in the position of my maximum bank that I'm happy with, I can hit Shift, right bracket, and now if I go back into the Inverse Kinematics info window, I can see there is a new maximum bank of 25.7 degrees, which you can see down here in the left window again is exactly the same as the number of my bank. If I move, once again, the opposite direction, now you can see the numbers change to a negative value. This would be the minimum amount of bank. So the maximum is the highest possible number, whether it's a negative number or not. It just means that it's the highest number. The lowest number is the minimum. In other words, this is a deeper into the negative values. I probably only want this to be able to go back about that far, so a negative 75.0 something. It doesn't have to be perfect. I'll go ahead and leave it about there. Now I hit Shift on the keyboard and then the left bracket key. And if I go back into the IK info, you can see now that it has a new minimum bank of negative 75.4. I need to do that to each of my individual pieces. I need to rotate it as far out as I'd want it to go, set my maximum, rotate it as far in as I would want to be able to rotate, and set the minimum with the Shift left bracket key. Now, because I'm not using Auto Key Adjust, I can just go back to my first frame, everything snaps back into position, and all my IK constraints are set up. Of course, I need to do that one more time for this. I had already done that previously to save some time. So let's go back to selecting the foot, hit I on the keyboard, and now I'll tell it to follow the goal object, and full time is still selected. Now when I lift the goal, the foot, you can see, moves up only as far as the limits of each of these joints will allow. So I drag this down, it will only come down as far as I've told it it can go, and it will only go up as far as I've told it. So it stops there and locks into position. I cannot lift up any higher. My goal keeps going, but not the leg. This is setting joint constraints. This is an important part of inverse kinematics, because this way the computer knows exactly how far a joint should go. Take, for example, an arm. An elbow on a human, or most normal humans, cannot bend any farther than this. It can bend only this far in this direction, and can't bend any farther back in this direction, or the elbow is going to break. So basically, you're just setting up very natural constraints for each rotation. In the case of our spider mech, the lower legs only rotate on the bank, so we only had to set constraints for the bank. We didn't have to worry about the pitch or the heading. For the upper leg, we're going to need to set constraints for the heading as well, but we won't do that until the next step. Before we can get on to the next step, the last thing we have to do is save the scene. So I'll go to File, Save Scene As, and select an appropriate name. I've selected Spider Mech Leg IK. And I'll go ahead and save that. Now, before we go on to the next step, one thing I'm going to show you is something you might run into. I'm going to remove the leg off of our hierarchy, off of our little leg. I'm going to do that by going to the Clear button and saying, yes, clear the current object from the scene. And that means it's no longer following the goal. So I'm going to reset this. Let's say I only had 3 pieces to the leg, and this was the last piece in the chain, as opposed to having the foot on the end. I'm going to go to the IK info for this and tell it to follow the goal and turn on full-time IK. Now you can see that when I move the goal around, the leg still follows it, but the lower end of the leg isn't moving along with the goal. It's not doing any rotating at all. The upper leg and the mid leg are rotating and still following it, but what is pointing at the goal is the pivot point of the lower leg. Because remember, we moved the pivot point of the lower leg up to where the joint would be so that the lower leg could rotate. Now if I wanted to be able to rotate this independently of the goal, this would be fine because I could still move the goal and then animate the leg. But to be able to use IK the way we were before, I would have to add what I call a pointer object. It's simply another null object that I'm going to add and move over to the end of my leg and parent to the lower leg. Watch what happens when I say OK. It shifted over. This is because I should have parented it before I moved it to the leg. Once again, when you're parenting, you need to make sure you parent before you move anything. So I'm going to have to move that back now. If I had moved it very far, it would have been a drastic move and we would have lost it. It would have been out in Never Never Land someplace. So it's important to remember to parent before you make any moves. I'm also going to name the null by hitting P on the keyboard for the Objects panel. I'm going to name it Pointer, simply to remind me that it's what is pointing at the goal. So I'm going to move the goal back down underneath the pointer. I'm going to select the pointer, go to its IK panel, once again select the goal and full-time IK, and now one more time, if I move the goal, it moves just like when we had the foot. So even though I have no real geometry on the end of this leg, I've added a pivot point by adding the pointer to the end of the leg, by parenting it to the end of the leg. The pointer is what's trying to reach the goal. So now, what we're going to do after we've saved this scene is be able to load from scene so that we don't have to do this for each independent leg. We've done it for one, why reinvent the wheel? I'm going to start by clearing the scene, and I have a scene already made up with the spider body that will load in, everything except for the legs. Once again, I'm going to go to the Objects panel, and I'm going to use the Load from Scene function that will allow me to load my spider mech leg IK scene into my current scene. It's asking me now if I want to load the lights from scene as well as objects. In this case, no, I don't want to. If I had, say, a light on the end of my leg that was flashing on and off with a lens flare or something like that, this would give me the option of loading the lights that I had set up and parented to my leg or my object as well. In this case, I'm going to say no, so it just loads the leg object, as you can see here. It also loads the goal object and any other nulls or associated parts and animation that's attached to this leg. Next, I'm going to select the upper leg. Let's go to the front view by pressing 1 on my keyboard. And you can see here that it's pretty much in position because this is where I modeled it. It comes right in. If I go back to my top view, though, by pressing 2 on the keyboard, you can see that it's directly in between the two leg pods here on the main body. So I have to start, before I move it, by parenting the leg to the front pod of my spider mech. Now it moved just a little tiny bit, and it's repositioning itself, aligning it with this object. What I have to do now is manually position the leg where I want the leg to be attached to the body. Now you can see, as I move it, the IK is still acting on the whole leg. So I'm temporarily going to turn off the IK. Let's go back to the front view and select the foot object. Go to the IK panel and temporarily turn off the IK for that object. I'm going to go back to the top view, and this will allow me to once again position the whole entire leg. I'm also going to rotate the leg on its heading so it's facing the direction I want it to start in at frame 0. And that's about where I'd like it. Before I turn back on full-time IK, the last thing I have to do is set up my rotation limits for how far this can move on the heading. So to affect only the heading limits, I'm going to turn bank off. Now if I go to the IK info, you can see my heading limits are not active yet. I have negative 180 all the way to a positive 180. And that's a full range of motion. So we need to go back to the rotation and set our limits again. We'll do it once again with the keyboard equivalents instead of writing down the numbers and manually placing them in. So I'm going to rotate it as far as I'd like it to move forward. And in this case, I can see that that's going to be the minimum value. If I look down here in the bottom left-hand corner at my heading limitations here, I can see that being far forward is into the negative axis. So that's going to be our minimum heading. And if I rotate it back the other direction, you can see that's going to be our maximum because this number is larger than this one. So that's about as far as I'd want to come forward. So I will push on the keyboard Shift, and for minimum, our left bracket key. I'll rotate it back as far as I'd want it to go. I don't want it to go too far back because when I have another leg here, they could collide. I want to make sure that they're not going to be able to collide. And so that is probably about as far back as I'd want that to be able to rotate. I push Shift again, and this time the right bracket key that will lock in that number. If we go back to the IK info, you can see right here, there's my minimum heading and my new maximum heading. And it also activates heading limits. Last thing to do is to remember to turn back on the bank, make bank active again. If I had had bank active when I entered those keyboard equivalents, it would have reset the bank as well, and that's not what we wanted to do. One more time, I'm going to go back to the front view and select the foot, go to its IK info panel, and tell it to follow the goal one more time. And now it snaps right back to where the goal is. If we look at this in the top view again, you can see now by moving my goal, I can move the leg only that far on its heading forward and only that far on its heading backward. So that's going to be the range of motion for the heading of the whole entire leg. Of course, our spider has more than one leg, so you're going to want to reload from scene with the other 3 legs and repeat the same process again. Let's take a look at the spider in action. You can see as he jumps off the table and lands on the floor that all 4 of his legs, or goals for each leg, articulate at the same time. Let me show you how I achieved that. I'm going to load the full Spider Mech setup with all 4 goals. You can see them here in the corners. I'm going to go to the front view, and I'm going to add a null object. This will come in right at the center, directly underneath the spider. You can see that in the top view and the front view. I'm going to zoom in a little bit because I'm going to start selecting the goals and parenting them one at a time to this new null object in the center. This null object is going to act as sort of a handle that will allow me to animate all 4 goals at once, and in turn that'll animate all 4 legs at once. This is going to allow me to gain control, for example, in bringing all 4 legs together, or all 4 feet together. We can achieve that by sizing this middle null. It actually sort of sucks each of the goals toward the center of this null object, pulling in the legs as well. I can make them splay out by simply sizing the goal. Now to make him land on the floor, I animated first the pod, which is the top of the hierarchy of the spider, and you can see his legs are wanting to stick to the goals where they are on the floor. So as he was coming down off the table, I had this main null goal, or main null object that is the parent of all the goals, directly ahead of him. I landed it on the floor just before he landed on the floor. So when he hits the ground, his legs resist, and I gave him a little bit of a bounce, sort of absorbing the shock of his landing. This can also be used for positioning his legs as he's jumping. Maybe I want his legs to be splayed out to the side, like he's flying to the side. I can move all the goals at once by moving the main null object that all the goals are parented to. This makes it much simpler than grabbing each of the goals and having to keyframe them individually. Of course, I still have the option of doing that one at a time, but when I want to move all at once, I simply grab the null and position them all. This is the basics of setting up inverse kinematics for a hierarchical object or a segmented object. So far on the tape, we've been learning how to animate based on pivot point or hierarchical animation, rotating and moving each individual piece of several objects that are parented together to create the animation. What we're going to be looking at now is anthropomorphic animation. We'll start with displacement mapping. I'm going to load an object that you can find in the displacement or displace directory within the new tech directory. I'm going to load displaced flat. It's simply a flat plane, but if we turn off the OpenGL, you can see in the top view it's quite well subdivided as well as triangulated. This way, when we start deforming all the points, we're not going to end up with rendering errors from non-planar polygons. I'm going to go ahead and turn OpenGL back on to get the best effect from this. I'm going to go back to my perspective view and zoom in a little bit. And I'm going to add a texture to our scene here. I'm going to load a simple image, and in the images directory you should be able to find an image called Weave Brush. It's a Targa file, and the nice thing about it is it has a lot of high contrast as well as some gradient ramping here going on. This is going to be very helpful because our displacement is going to happen based on the amount of ramping from this texture. I'm going to go to my Objects panel again, make sure I have the flat polygon selected, and down here about halfway is the Displacement Map button. Now you've seen on previous tapes the effect of procedural textures like ripples and fractal bumps. We're going to use a planar image map. If this were a cylindrical object, we could cylindrical map it or spherical map it. We'll use planar since it's a flat plane, and I'm going to tell it to use my Weave Brush as the current texture, which I can see here. I'm going to hit Automatic Sizing, which will make it fit all the way around our entire plane. I'm going to leave Width Repeat and Height Repeat turned on, since this is a wrapping texture. I'm going to add a texture reference object by clicking on the Add Reference Object button. You can see now that I have the reference object selected here in the texture reference object. I'm going to click on the Y-axis since we're going to project this flat down on the Y, and for now we'll leave the texture amplitude at 0.5. This determines how high the bumps will be, much like a displacement, or rather a bump map. Displacement maps are very similar to bump maps, except that you are actually deforming the geometry. Now that's probably a little high. In other words, for the amount of geometry we have, these are being displaced a great amount from where it originally started. So I'm going to reduce that a little bit and make this 0.2. And you can see the results of that here. It's a slightly more subtle look to it. Now I'm going to grab the reference object and I'm going to size the reference object. And you can see, just like with procedural textures, by sizing the reference object, I'm sizing the displacement map. Beginning to look sort of like an egg carton. Now the nice thing about this is that if I save this with Save Transformed in the Objects panel, this geometry will stay like this. So I can use this also as a modeling tool. This could be a grayscale image of someone's logo or a face. Anything that has a good deal of highs, meaning the light sections of the map, and the dark sections will become sort of the valleys in between. Let's see what fun we can do with this. How could we animate this? Maybe this isn't going to be an egg carton. Let's make it look more like, oh, a blanket or a quilt. Now I can do that by, first of all, sizing this down a little bit more, but I want to soften up the texture. And just like with regular textures, I have a texture opacity amount. Currently it's set to 100%. If I tone that down by dropping this down to, say, 30 or so, you can see the effect. It softens the effect of the displacement. Because it's just like a texture, I can also tell it to add a new texture. I start over again. So I'm going to remove that current texture and then close this because I want to add one more image to the new texture. So if I go to my Images panel, I can load another image. This time I have an image that I created that's just a image of, it's basically an airbrush from Photoshop that I just sprayed once in the middle of a brush. So it has a very white spot in the middle, a very quick gradient to a black outer edge, pure black. So that'll be completely flat, and this will be our raised area. When we add that to our existing texture, back in the displacement window, I'll say Add New Texture. It'll be a planar map again. I'll select the alpha spot. When we add this to it, the middle of our little blanket area should be bumpy and be sticking up. I'm going to turn off height and width repeat on this one so that I can move this around. Once again, I'm going to add another texture reference object. Now it says reference object 2 because we now have 2 of them. This will be the one we'll animate the spot with. I'm going to turn the opacity down so that we can see both textures simultaneously on our surface. And once again, I'm going to select the y-axis to project this down. I'll leave the texture amplitude of this one set to 0.5 and see how that looks. Well, there's a nice lump right in the middle of our little quilt. I have the second reference object selected, so now if I move it, you can see I can position the little lump underneath the other bumps. I can size this, and it will become a much more pronounced bump because the height is being controlled by the amplitude. I can give the amplitude an envelope to make it go up and down, literally grow and shrink. But as far as the width of the effect, that's controlled by sizing the reference object. So I can make it a rather large, puffy area, like someone crawling under covers. And if I wanted to make this a different shape, I can size it down a little bit, and I could use the stretch tool. So I could stretch this in one of the axes and make it a very narrow lump. I can also rotate the texture reference object, which will rotate the texture. So if I combine these effects, I can animate it by keyframing it. So if we start with it here, drag forward in time, rotate it around a few times, position it, move forward in time again, position it again, rotate a little more, drag forward in time, keep rotating it. We're going to get a very strange effect. Some sort of strange creature is crawling under our covers. At the same time, I can also size it up a little bit too. Let's see what that looks like when we play it back. It's a very interesting effect. Now imagine you had a small mouse object that ran underneath a carpet, for example, and began chasing something underneath the carpet. this is one of the only ways I could imagine achieving that same results. So this is a look at actual texture maps as displacement maps. And remember, if you save transformed, you can also use this as a modeling tool as well. Along the same line as displacement maps and other anthropomorphic animation are a new plugin called effectors. And this is a little plugin that's kind of overlooked a lot. And it will give us a little more control with our displacements of points on our objects. Let's take a look at how to use these. First, if I load a scene that comes on the 5.5 CD-ROM, it's in the New Features directory, and it's oddly enough under Effectors. So I'm going to load the Effector cow scene, and you could load this too and follow along. It's not just educational, it's fun. I'm going to start by, you can see here I have a null object that's been renamed Effector. And I have our good friend the cow object. And if we look at the objects panel with the cow selected, you see here under displacement map plugins, it's got the Effector plugin. Under the options of the Effector plugin, I'm telling it that I have a null object named Effector that I want it to track. I have some information here such as solid core radius and fall-off distance, which I'll explain in just a moment. Let's start by positioning our object up the y-axis just a little bit and a little closer to our cow. And in fact, I'll move the whole view over just a little bit. Now I'm going to grab the cow object and move it forward. You can see already, as soon as I start moving the cow, it's being affected when it comes near the null object. You can also see from this that it's a spherical radius that's being affected. That's because effectors start off with a spherical radius, and that's what I'm going to change right now. Back in the effector options is the fall-off distance of that radius. So if I bring this down more closer to, let's say 2, and then move the cow, you see that now it has a slightly different effect on the cow. We can also affect this by moving the null and animating it, as well as sizing and positioning. So let me clear that scene out and load another scene that ships. This is more of a real-world example. I'm going to load the scene called Effector. It's a tube object and a sphere or ball object. Now, neither of these really are doing much of anything. The object that's doing the work, once again, is our effector object. It's a null object, and you can see that it has a motion path applied to it. It's traveling through the center of the tube. The ball is parented to the effector. So I'm not moving the ball, but rather I'm moving the effector. Watch what happens as the effector and the ball travel through the tube. It looks as if the ball is displacing the tube, trying to squeeze through. You could picture this being used for an ad maybe for a drain cleaner. It's a very strange effect. It's much like the old mouse running under the carpet that I was talking about earlier on the tape. But instead of a displacement map, we're using an effector. Now there's another way that you can change the radius or the influence of the effector. I'm going to go back out to a different directory and load a scene that I just created recently called Ball Bounce. It's just another little ball and a big flat plane. Underneath the plane is another null object. You can see it hiding underneath there. Only it doesn't look like your traditional null object because I have flattened it in the y-axis. Literally stretched it down. You can see here in the scale in the bottom corner window that the x scale is set to about 2, the y is 0.01, and the z is 2. So it's rather large but very flat. This is very important. By scaling the effector, we can scale the effect of the effector. Watch what happens when I hit play now. All I did was animate the ball bouncing up and down. The effector took care of the rest. Let's look at what I have set on the ball. If I go to the object panel for the ball, you can see I have an effector applied, and you can see here that the core radius is smaller than it was for the cow. It's set to 0.001, and the fall off, instead of being set to 10, is set to 1. And by sizing the null object itself, I've made the effect very flat. And then I simply placed the plane object, just the big blue plane, underneath the ball. The plane has nothing to do with it. I just very carefully placed it exactly where the effect started. Let's see what happens if we size the null back up just a little bit in the y-axis. You can see now it's giving us a different effect. It's flattening out even more. If I size it larger and move the ball straight down, you can see it squashes it out even further. So by playing with the size of the effector itself, you can greatly change the effect it has on the object. So this is effectors, and it's one way of enhancing your animation. An example of this would be on the tape again, our animation of the fly. When he spews the green gook out onto the camera lens, imagine taking a ball of clay and throwing it toward the camera and having it stick to the camera lens. It could be flattening out, and you could use an effector very easily to achieve this results. Along the same lines of displacement plugins are some modeling tools in layout that we can animate with. Let's start by loading an object off the content CD. You'll find it in Household Bathroom directory, and we'll load the spray bottle. I'm going to zoom in a little closer, and I'm going to go to the front view. And I'm also going to turn off the OpenGL so we can see a little bit better what we're doing. I'll zoom in a little more. Now I'm going to add two null objects. One of them I'm going to move up the y-axis to the top of the bottle, and these are going to be what we use to deform the bottle. We're going to be deforming the bottle much like our displacement maps did, but this time we'll be using tools like bend and twist. These are basically the exact same tools that you use in Modeler. Now I'm going to go back to my null objects, and I'm going to rename them by saying Save Object and then typing in a new name. Just so I don't get confused, I'm going to type in the name Handle, and on the other null I'm going to type in the name Base. And once again, I'm going to check to make sure the base null is at the base of the bottle and that the handle is up here at the top. Once again, I'll select the bottle and go back to the Objects panel. And I'm going to go to the Displacement Map, Plugins, and add Twist. I'm going to go to the Options for Twist, and where it says Effect Base, I will pick my base null, and where it says Effect Handle, I'll select the handle null. Since the spray bottle is vertical on the y-axis, I'll keep the y-axis selected. I also have choices of my fall off. I'll go ahead and leave it set to smooth, since that'll give us the most organic sort of a twist. I'll say OK to close that, and then close the panel. Now by grabbing the handle null and rotating it on its heading, I can twist the bottle. Let me go ahead and turn on the OpenGL so you can see the full effect of the twist. You can see this is a very cartoony sort of a twist. A little bit of stretching and squashing going on, we can achieve more of that by animating or positioning the base null. So if I select the base null and move it up the y-axis to right about where the neck is, and then select the handle and rotate it once again, you can see now he's really twisting his head. It is deforming as it twists, which does give it that sort of cartoon effect. Now this bottle has not been very well subdivided. They have not been triangulated either, which means we might get some rendering errors. It's always good to remember to triangulate the objects if you're going to be using displacement maps or bones or morph targets or anything that's going to be displacing the points and causing them to become non-planar. Once again, I can animate this effect by moving forward in time and then dragging the base null back down to the bottom. Let's go ahead and rotate our null and go back to the beginning and play that and see what happens. You can see that the twist sort of starts here and then continues down through the body. This is going to help us create some very rich character animation by creating not only just twisting and bending, but also being able to cause a twist to go throughout a whole entire object. Let's start by deleting this keyframe at frame 14 so we can go back to where we started. And I'm going to, once again, pull the base null back down to the bottom. I'm now going to add another null object and position it down by the base. I'll go to the Objects panel, and I'm going to name that null as well. This will be our bend base. I'm going to go back to the spray bottle object and go to the second displacement map plugin slot and add the deform bend tool. To make it active, I'll go to the options panel, and for the effect base, I will select the bend base null. And the handle, I'll select the exact same handle that I was using for the twist. Once again, it's going to bend along the y-axis. Now if I grab the handle null and move it, the spray bottle will bend. Let's go to the perspective view so we can get a little bird's eye view of the animation going on, because now I can animate it in all three dimensions. I can move it left or right, back and forth, and I can pull it down. The handle is actually moving now down to about halfway up the bottle, and if I animate that, now you can see the top is staying more rigid and he's bending lower down his body. At the same time I'm bending, I can still rotate and achieve a twist. In fact, if I twist and then move, you can see he's rotating and twisting as well as bending. Now the reason I have two different base nulls, it's not a necessity, but the reason I did that was so that I could grab the base that's attached to the twist tool and move it up so that the twist is only happening toward the top. Yet the bend is still happening all the way down to the bottom where the bend base null is. Once again, if I twist this, he can still twist his head at the same time he's bending, but it's only the top that he's twisting. Once again, if I animate this, moving down, you see the twist happening over time, sort of going throughout his body. With a little more creativity you can get, and timing, you can get some pretty interesting results. In fact, let's take a look at a little animation that I sort of whipped together using these exact same deformation tools with two base nulls. You can see I also added some other tools to the animation, such as the stretch tool as he flies in to add some squash and stretch. As he shakes his head, it does give that sort of Hanna-Barbera cartoonish effect as his head deforms when he shakes his head. And then you can see how, once again, the twist travels down the body and he continues to bend until he hits the camera. Well, that was an example of character animation, and if you're new to character animation, that might be biting off a little bit too much. Let's start with something a little bit more realistic. In fact, it's something that we used in the bug-off animation. If you remember the cockroach dancing back and forth as the missile was coming toward him, you may have noticed, or not, that his antennas were swaying back and forth. Now originally I was planning on using bones to deform these, and I realized that was going to slow down my computer and in turn slow down my workflow. So I decided to try using one of our displacement plugins. In fact, I used Bend. I'm going to load a scene of just the cockroach's head. You can see that the antennas come in perfectly straight. This is how they're modeled. And each antenna is separate from the head, but they are parented to the head, of course. So that way when I move the head, the antennas move with it. I also have a couple of null objects. A left antenna base, which is hiding right here. And I'm going to go to the side view, or left view, and I'm going to position the base right at the base of the antenna. I'm going to select the left antenna control null and move it up the antenna. Now you can see once again I've locked off the Z channel. I'm only moving in the X and the Y, making it easy to slide right along the antenna to the top. I'm going to do the same for the right antenna control, on up to the top. And I'll make sure the right antenna base is positioned right at the base. I'm going to go back to the front view and move the right antenna base over underneath the right antenna. And the same for the left antenna controller. I'll move that over to the top of the left antenna, and the right antenna controller directly above the right antenna. At this point, it's probably a good idea to save the scene. I'm going to go ahead and save right over that one. And now, once again, I have to apply my displacement plugin. So I'll choose first the Roach left antenna, go to the Objects panel, and select Deform Bend. Once again to the Options panel, the left antenna base as the effect base, and the left antenna controller for the handle. Now you don't have to name it handle. As you can see, I've named this one control instead of handle. Once again along the y-axis. And now I'm going to move to the right antenna, apply the Bend plugin, go to the Options, find the right antenna base for the effect base, and the right antenna control for the effect handle, and make sure the y-axis is selected. Close the panel, and we're ready to animate. We do that by simply grabbing one of the controllers and moving it, and I'm moving it only in the x-axis. The Z is locked off, so I can't accidentally move it into the Z. I only want it to bend left and right. And as you can see, if I move it all the way over, the antenna is practically wrapping around itself. The whole entire antenna is bending. And of course we know that we can modify this by positioning the base controller higher up the antenna. So now it'll stay straight and rigid from here up, and from here up will be where it bends. This is giving us a more realistic effect. I could move this antenna over to the side a little bit and change the effect, as well as I could also move the antenna controller down the y-axis slightly, and now when I move it in the x-axis, you see that the tip of the antenna is also staying rigid and straight, which is much more realistic for a cockroach's antenna. It's straight at the beginning, bent in the middle, and straight at the end. Of course, I can animate all of these effects over time by giving it keyframes. So I could really create sort of a wobbling effect by starting at 0 here, moving forward in time, pulling it up, moving this over, moving forward in time some more, animating this back over, select the other null, and pull it back down. And if we hit play, we can see how that looks. It's going to sort of sway back and forth. So this is a very simple, real-world example of how it's very easy to apply something like the bend tool, which is a modeling tool, but animate it in layout to achieve a very simple effect that would otherwise be a very difficult thing to animate. To gain more control in our animation, we can use bones. Bones is another form of displacement, which is actually displacing or deforming the points of an object. But instead of like a displacement map, where it's an image, or a displacement plugin, where it's just over a range or an area, bones can specifically affect particular areas and give us much more control. And that's what we're going to be looking at next. We'll start by loading another scene that comes on the Content CD-ROM. You'll find it in the New Features folder within the Bones folder, and it's called Arm Setup. This is supposed to represent an arm. It's probably one of the worst modeling jobs I've ever seen, but it'll get the point across. I'm also going to turn off the OpenGL temporarily so we can see the bones inside of the mesh. To see them better, I'm going to go to Bone Mode under Edit, and that way they'll be highlighted. I have 2 bones in this arm. This will represent the elbow position. Let's start by rotating the bone, and you can see I only have the pitch activated, so it'll only pitch, much like your elbow. So now you can see that the bone is actually deforming the mesh, and now I'm going to turn OpenGL back on so that you can see it's not only deforming the mesh, but it's also squeezing the mesh. This does not look like an elbow. This looks more like a garden hose. Now there's a reason for this. One of them is that you might want to actually animate a garden hose doing this sort of a kink in the middle of it. But for an arm, we're going to need to change some of the bone's attributes. So by hitting P on the keyboard to go to the bone panel, which is by far the fastest way to get to the bone panel, we can see that there's a lot of options for bones. For now, we're going to concentrate on this lower area. There's something called joint compensation and joint compensation for parent. Now we are on the forearm bone, and so if we add joint compensation to that bone, as well as joint compensation for the upper arm bone, you can see that now, by rotating the bone again, the elbow stays more rigid. Instead of folding and creasing right here, it stays more rigid, more like your elbow would or my elbow would. Much more realistic. There's something else missing, and that's that when you usually make this sort of shape with your arm, changes happen to your muscles. Some of us more than others. I'm going to hit P again on the keyboard, and we'll make some of those changes. Typically, your forearm muscle doesn't flex, so I'm not going to activate that right now. I am going to activate muscle flexing for parent, which would be the bicep. You can see already that when I've bent the arm, the muscle bulges. Now this is only controlled by the pitch of the bone. The heading or the bank of the bone will not affect this at all. So it's important to place your bones accordingly. Otherwise you may have a muscle bulging out the side of the arm. Once again, if you pull this down, the muscle will bulge out the bottom. This is not necessarily a desired effect, but this is because I'm allowed to bend the bone all the way back over. In a while we're going to add some IK to a chain of bones, and of course then, just like with our spider mech, we could add constraints so that the arm couldn't bend any further than here or here. In this case we can keep going, and ow, that's gotta hurt. So let's look at some of the other attributes of bones. This is usually how you're going to be using them, deforming a mesh as a skeleton in a character or other anthropomorphic animation. But there's a lot of other options in the bones panel. I'm going to load a scene that I created, and this does not come on the content CD-ROM. You'll have to create this on your own. But I have one called Bones Fall Off Scene, and I have a checkerboard pattern. It's simply a flat checkerboard object, a one-sided polygon, but you can see I've got a total of 5 bones, one in each corner and one directly in the center. This has become sort of my bone test pattern so that I can easily figure out exactly what I'm going to get from the bones that I have applied in my scene. I'm going to select one of the bones up in the top corner, and I'll start by just moving it around. And you can see exactly the effect the bone is having on the entire mesh. To see what we have going on, I'm going to hit P on the keyboard, and you can see I've got pretty much a plain standard sort of bone, kind of the default settings on the bone. Now this scene is set up to show us the different fall-off types. The original bones in Lightwave, the fall-off was a linear fall-off. It just started from the center of the bone and started falling off, and it looks something like this when you moved it. It immediately started falling off, and you can see how if I pull this directly out here, the only place the bone is really pulling is the one point it's on, and it immediately starts falling off, and it keeps falling off in a very linear fashion. I'm going to hit P again to bring up the panel, and I'm going to change the fall off type back up to 4, and now you can see how it's affecting a broader area. Now the fall off types have to do with how close 2 bones are to each other. If you only have one bone in an object, it'll move the entire object. You need other bones in an object to anchor or pin down other areas of the object. The fall-off is based on how close one bone is to another. So the fall-off is between this bone and its nearest neighboring bones. You won't see much of a difference because the bones aren't gathered in a very close layout here on the object. But I'm going to hit P again and change this all the way up to 16. This is giving it more of a very quick fall-off. It's falling off much faster, and you can see the effect how it's ending right about here as the other bones are starting to take control of this immediate area. It's much more powerful right around the bone itself, and the fall-off is a very limited area between the other bones. Setting up a test bed like this, or test pattern like this, is an easy way to see all of the effects of bones. I have another scene set up to show a different type of bone characteristic. This is the limited region effect of bones. And if we look at this, you can see there's little lines encompassing each of the bones, except for the 2 lower bones, which are set up as normal. This is the effect of limited region on the bone. So if I go to the bone panel, you can see that now the check mark is activated next to limited range. You can also see there's a minimum range amount and a maximum range amount. So looking here from the front view, if I move the bone, you can see that it has a definite limited range. It's not affecting anything outside of these dashed lines. It's sort of a capsule shape. You can see there's absolutely no fall off. These points are within the range, so they're moving with it. These points are within the range, and they're not moving it at all. If I change that range to a minimum of 0 and a maximum of 1, you're going to see that the effect of this starts, the minimum range starts directly at the center of the bone and then falls off to the edge of the limited range at 1 meter. So you can see now it's immediately falling off, much more like our first style of bone that we were looking at before. yet it ends within that minimum range. So the fall off starts here and ends here. You can achieve quite a varying results by changing these amounts, either fully encapsulating by making them both the same, or by having one set to a low number and one set to a high number, which is the case of our middle bone. Let me move the camera out of the way and select the middle bone. I'll hit the P again to bring up the panel. You can see the minimum range is set to 1 and the maximum range is set to 3, which means it's coming all the way out past our grid. Each one of these 4 squares represents 1 meter. And this is going out all the way out 3 from the center of the bone out. So if I move this, now you can see that a 1 meter area is fully affected by the bone, and then the fall off happens from the 1 meter area all the way out to the 3 when it falls off completely and no longer affects the pattern. I've set up several other scenes like this, and another one of those would be bone strength. This is a very confusing thing for a lot of people. Bone strength is something that is very difficult to understand because it's not used very often. I've got 2 bones right here in the center. There's the standard 4 bones on the corners, and I've added 1 more bone in the center. If I go to the bones mode, you're going to see there's 4 bones named bone, 1 named test in the center, and 1 named strength 5. Strength 5 has a keyframe at 10 that pulls our mesh out and down along the z-axis. I'm going to go back to the top view so we can see exactly how far it pulls out. It's a total of, if we look down here at our grid size, we can see it's 1 meter. It pulls out a total of 5 meters, and the bone strength is set to 5 here in the bone panel. Set to 500%. And so we named the bone strength 5 just to remember. The other bone, called bone test, which is sitting down here at 0 and not animated, if we look in the bone panel, you see the bone's strength is set to 0. It has absolutely no effect on the scene whatsoever. If I change this bone's strength to, say, 100%, and then if I move the slider a little bit, you'll see what happens is that the checkerboard drops back down almost a full meter. So I've given this bone a little strength, and it's trying to pull this back down away from the very strong 500% bone. If I give this even more strength, say 300, and then pop the slider over a little bit, you'll see that it's pulling it down not as far as it did before, because they're starting to even out and this one is stronger. Don't forget, it's a percentage, not a distance. If I make them both even at 500%, it should be exactly in between the two, basically a 50-50% pull. This is good to know if you have 2 bones affecting the same area and you want one to be able to pull a little more on the points than the other bone that's also affecting the same area. I really suggest setting up your own pattern and trying various combinations of bone fall off, bone strength, and playing with the limited region to see the different effects you can achieve for each of your different animations. Now we're going to take a look at bones in a more advanced level. I'm going to apply a chain of bones to an object and animate it much like I did with the displacement tools. But we'll see how we can achieve much more realistic results and controlled results by using bones. We're going to start by loading another scene off the content CD. This one's in the tutorial folder called Spray Bottle. This is a scene that was really originally used to show front projection image mapping, but because it also has some animation of the spray bottle using bones, we're going to use it as an example of different bone setups. You see this spray bottle sitting here. They positioned this spray bottle to be looking down at the other bottle by simply placing 2 bones in the spray bottle, one at the bottom to act as an anchor or a base bone, and another bone at the top to animate the head or position the head. Now, because they were just positioning it, they didn't need a lot of control. I personally like this kind of animating with bones because it reminds me of rod puppets, which were puppets that had sticks going back through the curtains that you would then position and twist and animate your puppet on stage. This is much like a rod puppet. I can move these bones up and down and around and achieve some pretty interesting results. I could have applied more bones to get even better control. However, this still isn't as much control as the bones in this bottle. And that's because this bottle has what's referred to as a skeleton of bones, going from the base up to the top and around the neck. This enables us to use IK to animate the spray bottle, just as we were using IK on separate pieces of objects on our spider animation. One thing I would like to point out, let me find a good position for this. Here we go. I want you to see the trigger. There is a bone in the trigger. It moves along with the rest of the bottle. You notice the trigger never really moves while he's sniffing the side of the tub. I'm going to rotate this bone as if it was squeezing the trigger. Notice how it sort of starts deforming the rest of the bottle as well as deforming the trigger itself right at the base of the bone. For a character, this could be acceptable, but in a moment I'm going to show you how to put a chain of bones into the spray bottle as well as how to keep that from deforming the handle and the rest of the spray bottle with it. This is a scene that you can load to see exactly how these bones are placed in both of these bottles. I'm going to clear the scene and load just the spray bottle object from the CD-ROM. You'll find it in Household, Bathroom. I'll just load the spray bottle. And there's something else I'm going to need to do to this bottle to effectively place the bones. Since when we load a bone, it comes in along the Z-axis, it would make more sense to have our bottle facing along the Z-axis. Let me make sure I'm making myself clear. I'm going to add a bone by selecting the spray bottle, going to bone mode, and just tell it to add a bone. See what I mean? The bone is facing along the Z-axis. The bottle is facing along the X-axis. I'm going to clear the bone, and I'm going to go into Modeler, get the spray bottle, rotate it, and put it back out into Layout. So I go to the Objects panel, Get. The only thing I have in my scene is spray bottle, and it loads it in. I'm then going to use the R command, which is rotate exactly 90 degrees. And that's going to face the bottle directly along the Z-axis. If I didn't want it facing into the positive Z-axis, but rather the negative Z-axis, I could use the E key to flip it exactly 90 degrees the other direction. Notice I placed my cursor right in the center of the bottle so that the rotation would happen around the bottle's center. I think I'll have it facing the negative Z for now, and I'm simply going to put the spray bottle back in as spray bottle. And I'll go back over to Layout. Now you can see our bottle is positioned along the Z-axis as opposed to the X-axis. This is going to enable me to add bones to this in a more natural manner. It'll also avoid something later called gimbal lock, which we might have run into if I had left it along the X-axis. As you become more advanced in your character animating, you'll start learning more and more about our friend gimbal lock. For now, I'm going to turn off OpenGL so we can see the mesh and see where we're placing our bones. I'm going to go into the top view and zoom in so I can see exactly where the bones are being placed in the base. We're going to start with a very small bone at the very bottom of the bottle. I am in bones mode. The bottle was selected. I'm going to say add bone, and you can see the bone comes in rather large. I think it defaults to about 1 meter. This is no problem. We're going to scale the rest length of the bone down. The rest length of a bone is where the bone sits when it's inactive, when you're not moving it. That's where it starts. That's the position that it where it's affecting the mesh, is the rest position or rest length. I do not want to size the bone. If I size the bone and then activate it, it's going to shrink that part of the bottle. Why? Well, that's so that if I wanted to animate the bones shrinking an object, I could. I don't want to start off that way. Instead, I want to go to rest length. That will also size the bone down, but it's sizing the resting length of the bone. That's where it will become active. I'm going to go to the side view and look at this. And I'm going to add another bone, but it's got to be a child bone of the small bone we just placed. Why did I make this bone small? I'm glad you asked. This is going to basically be our handle or our null bone. In other words, it's the main point that everything is going to be parented to. All the other bones will be parented to here. If I need to move all the bones at once or the whole bottle, I can grab this one and move it, or I could grab the whole bottle and move it. So I'm going to go ahead and say add bone, but it's going to be add child bone. When I do this, a 1 meter bone doesn't appear. Instead, another very small bone appears right next to our original bone. That's because it takes on the attributes. Child bones, when added, take on the attributes of the current bone. This is no problem. I'm going to size it back up. I wanted to control the size of the rest length anyway. And then I'm going to position it. I only want to position it along the Z, so I'm going to turn off the X and the Y for now. And I'm going to slide it forward. I'm going to go to my top view, and now I'm going to only move the X, and I'm going to move it over to the side. These are going to basically be 2 feet, or 2 bases holding up the bottom of the bottle. So I'm going to create another child of this bone, add child bone, and you'll notice that when I add a child, it pops in at the end of the bone. This is important because usually you're adding children along an arm or along a leg or along a tail, and you want them to come in end to end. It's not an issue because I can always move it back next to the other bone. And I'll hit 3 on the keyboard to go back to my side view and make sure it's appropriately placed in this view. Now I'm going to go back and select my original bone. While I'm at it, I'm going to hit P on the keyboard to go to the bone panel, because I can rename my bones as well. Just like renaming a null object, I'm going to rename the bone. Since this is my main bone, or my small null bone, I'm going to call it main null. And that way I remember that this was the small one that I don't really want to animate. It's just sort of my anchor bone that holds everything together. These bones I'll rename, and I'll call them base. If I name them both base, Lightwave will give them a 1 and a 2 next to them, so I won't get confused. Once again, I'm going to select my main null and close the panel. Now I have my small main null bone selected, and I can add children to it. I'm going to do this in the front view. And I'm going to zoom out just a little bit so I can see most of the bottle. Once again, I'm going to use the bones add, but this time I'm going to tell it to draw child bones. This allows me to place my cursor where I want the beginning of the bone. Actually, it's going to snap right to the end of our bone, but it'll allow me to draw it from that point up a specified amount. Instead of changing the rest length, I'm sort of changing the rest length on the fly this time. So I begin dragging with my left mouse, and you can see the bones getting smaller and larger, just as if I was changing the rest length. And once again, it's happening directly from the center of the bottle. So if we look from the side view, you can see that's going to go straight up the center of the bottle. I'm going to go back to the front. And now that I've clicked somewhere else on the interface, once again I have to say draw child bones under the bones add button. So it knows I want to continue drawing child bones. I'm going to make them all about the same length. I don't have to be completely accurate. And you can see I can continue drawing child bones as long as I don't click another button or outside of the interface. I'm going to make sure that this bone ends right here at the neck because I want to be able to twist the bottle at the neck. At this point, I'm going to go ahead and change back to my side view because I want to start angling the bones. this is probably the bone that I'm going to parent the trigger bone to later on. So I want to make sure I have a location. Now I moved the bone because I forgot to click Add Child Bone. No problem. I'm going to say Undo Move, and it'll put it back where I had it. Now I'm going to say Add, Draw Child Bone, and continue dragging and drawing the next bone. About there. And one more here coming toward the front, and one more right near the spout. And then I'm going to draw one more very small bone, just like our null bone at the bottom. Only this is going to act as our pointer bone. So when we add inverse kinematics, one more time, if I had used this bone as the pointer, it would be pointing from back here where its pivot point is. Now it's going to be where the little null bone is. So the very tip of this will point toward our IK goal. Now all that's left to do is activate these bones, because right now they're just dashed lines and they're very difficult to see. I'm going to activate them by hitting R on the keyboard, which is rest. R for rest. I'm going to hit R and it becomes active. I'm going to use the up and down arrow keys to sort of curse right through all of my bones. I'll hit R each time as I go through and they become active. Something I want you to see is if I had started at the bottom bones down here and hit R, the bottle may have started changing its position. It didn't this time because I already started activating other bones up here. I also need to make sure I activate these two base bones. There, you see the bottle sort of pop right there for a second? That's because I activated one side but not the other. So now once more I want to make sure I go through my chain and make sure all the bones are activated. It's looking good so far. At this point, you're probably going to want to save the scene. You want to save it as something new. Don't save over the old spray bottle scene. Maybe I'll add this to, say, spray bottle bones. So I know this is my bones in my spray bottle. It's good to save it along the way. That way, if you make a mistake later on, you can always come back to where you were and you don't have to start over again. One other thing we need to do, or rather we don't need to do, is set constraints for these. Because I want my bones to be able to bend in every which direction, I don't need to set any rotation limits or constraints on my bones when I'm using the IK. The next thing I'm going to do is add a null object. I'll go back to Objects, Add Null, and this is going to be our goal, so I'm going to place it up here near the tip of the spray bottle. And I'm going to go to the Objects panel and rename the null, and I'll call it Goal. And before I activate IK on my pointer, I need to make sure I come down to the very bottom bone of the chain, the main null bone, and I'm going to go into the IK options panel by hitting IK info, and I'm not going to give it a goal object. Instead, I'm going to use something we didn't use before. I'm going to tell it that it's unaffected by IK of its descendants. What this means is that the other bones in the chain will be able to move, but this bone will not move based on the IK goal. This is very important. It cuts the chain in half. It says this part of the chain can move based on the IK, but these base nulls that are parented to the main null can't move based on the IK, and the main null itself can't move either. If I had set up the IK and moved the goal, the whole entire bottle would have swung around wildly because all of the bones would have been flying around based on the position of this null. So now I can go ahead and select the very tip bone, and I'm going to go ahead and, once more, go into the bone panel. And just so you know, to get to the bone panel without hitting P on the keyboard, I would select Spray Bottle, Object Skeleton, and that brings up the bone panel. It's much easier to use the keyboard equivalent. I'm going to rename this little bone Pointer Bone, because that's the one pointing toward our goal. And I'll close the panel. I'm going to enter the IK info panel for this little pointer object, and of course select goal as the goal object and turn on full-time IK. Looks the same, looking good. Let's go back to our objects, and I'm going to select the goal. And now if I begin moving the goal, sure enough the spray bottle follows right along. Now this is where I mean setting unaffected by IK of descendants keeps this locked right down flat on the ground, because these bones are holding it tight to the ground, which means I can make him move and sway and rock around, just like the one in the bathroom that you saw. He can sniff, he can move. The one thing he can't really do is rotate his neck or his head. And that's because this is all being affected by the IK, so it's very difficult for me to go in and try to rotate this bone or position it. It's going to do very strange things, and it's not going to act properly. The way I'm going to handle this is with a second null. Now, something you need to know about this is I'm going to add another null, and before I move it, once again, I'm going to parent it to the main goal. This is so that when I move the front goal, the back goal will move as well. So you've got to remember, parent it first, then move it into position, and then we'll set up the rest of the IK chain. So I'm going to start one more time by going to the objects and then saying add null object, and there it is. Now before I move it, I'm going to go to parent. I'm going to select my original goal object as the parent, and you can see it pops right up next to it. If I had moved it first and then parented it, it would have popped way up off the screen and I would have had a hard time finding it. So now I'm going to move it into position right here next to the neck bone. This is going to be the IK goal for this particular bone right here, which is going to take care of the rest of the neck. It'll be able to twist and rotate in every which direction. In order to do that, I'm going to go to the IK information and select the goal object as the null. If I wanted, I could name that null neck goal or something of that nature. I'm going to turn on full-time IK for that object, and I'm going to use something called match goal orientation. This means when that null rotates, all of the other descendants beyond that will rotate with it. And as you can see, it automatically rotated. That's because when I parented my null, it was based on the rotation of its parent. So what I'm going to do, because this is twisted on the pitch and the heading, is simply rotate this back into position. I might as well do it numerically by hitting N on the keyboard to bring up the numeric panel. And then I can change the heading, and I'm not sure even which way. I'm going to guess that it's a negative 180 degrees. Let's see what happens. Yep, sure enough, it bounced back the other direction. Now I've got to adjust the pitch. In other words, this was twisted all the way around on itself. And I'm going to hit numeric again, and I'll change the pitch. And that should be a positive 90 degrees. Nope, I was wrong. I should have put a negative 90 degrees. As you can see, it rotated back down even further than it was. So I'm going to hit N on the keyboard again and type in negative 90 degrees. Once more, I rotated the pitch, or the heading rather, I'm going to go ahead and change that back. Oops, there we go. All set. Now we're back up straight. Now I really only want to rotate this by rotating its parent. But you can see the effect of this. If I do rotate this null on, say, just the heading, you can see it's going to twist the neck of the spray bottle. If I rotate this, I'm going to undo that rotation. If I rotate just on the pitch, you can see it's pitching the neck of the spray bottle. I'll undo that rotation. However, since I'm using this main goal to position the bottle and move it, it would be very handy if I could just switch to rotate and have this neck rotate as well. And because I've parented this null to the goal, by rotating the goal, it's also rotating the null. But notice what it's doing. Let me turn on the OpenGL now since we know where the bones are. And I'm going to turn up the ambient lighting for now so we can see this a little better. If I rotate this, notice it's not just twisting the head, it's also swaying the body as if it's moving the shoulders of the bottle as it looks. If you want to rotate just the head, it's not a problem. Just grab that null and rotate just it. In fact, you could probably combine these to get a very interesting effect. Maybe he's peeking around a corner. This gives you a lot of control for character animation. There's a couple of other things that we can do to the bones in this chain. One of them is a new feature in 5.5 called pitch or rotation stiffness. In our case, I'm going to stiffen the pitch of some of the bones, and I'll show you how to do that right now. Okay, one thing to remember before we clear out this scene is to save this bottle with a new name, because we changed the rotation or the orientation of this bottle back in Modeler, and we used the get and put, and we had not saved this bottle yet. I'm going to go ahead and load a scene that I already had created, and it's called pitch stiffness, because I'm changing the stiffness of the bone's pitch. I'm going to go ahead and turn off the OpenGL again so you can see exactly where it's happening. This scene is already set up so you can see the effect, and then I'll show you how I did that. If I move my goal, you'll notice there's only one goal. I don't have the neck goal anymore. This is a different way of affecting the neck or bending the neck. It's going to give me a different result. This looks pretty much the same as it was before, but if I move the goal up and down the y-axis, you can see I can make him nod his head up and down. So he can bend at the neck more readily than he bends here. If I keep bending, eventually these bones will arch, but they're not bending as drastically as these bones down here. This is due to the fact that the bone at the neck here, if we go into the IK info, you can see it has a pitch stiffness of 100. All the bones below it have a pitch stiffness of 100 as well. The bone just up the chain from that one, back in the IK info, you can see has a pitch stiffness of 0.5. It defaults to 1. Now I could do this to the heading, the bank, as well as the pitch. I chose just to do it on the pitch for now. What this means is that this pitch, the pitch of this bone, is going to pitch more easily at a lower number than these bones at a higher value. So this will bend first, along with all the bones in the chain above it, and these bones will bend less readily. If I wanted this bone to break or change more easily than this one, I could go on up the chain and make each one progressively more stiff. This means by the time I get down to the bottom of the chain, it may well likely not want to bend at all. Let's see the effect of that. The neck bends pretty easily. The next bone bends, and these bones are having a very difficult time. I have to pull the null very far down. This bone is barely bending at all. You can see the effect of that. A greater arch here than over here. So by playing with the pitch stiffness, you can get a very interesting results for your character animations using bones. Earlier, I mentioned fixing the trigger squishing and bending, and that's what we're going to do right now by using a separate bone to isolate this trigger. Now, the one thing I have to do is move the trigger. I want it to be a part of the same object, but I want to move it. So once again, I have to go back into Modeler. I'm going to get the spray bottle, and this is the new one I've already saved along the Z. And I'm going to just select the trigger. So I can select part of the polys on the trigger, use the right bracket key again to select connected, and that selects the rest of the trigger. And I'm going to go to Modify, Move, and I'll hit N on the keyboard for numeric. And I'm going to offset this in the x-axis a couple of meters or feet, a couple of units over to the side. And now I'm going to go back to the object panel and put the spray bottle back. And we'll go back to layout. And now it looks like the trigger is still there. But if we look over here, you'll see it's set over to the side, quite a distance. This is important. I'm going to go back to the top view, and you can see how I am indeed still animating the whole entire object, the trigger included, even though it's sitting out here. This is using that same IK chain with the pitch stiffness. And I'm going to go to the side view or left view, and I'm going to select a bone which I want the trigger bone parented to. And I think this would probably be a good location. It might be this one. It might take some experimentation to see exactly where the rotation point of that bone is going to be. But I'm going to start by deactivating this bone. There's two ways of doing that. One, I can hit P on the keyboard to go to the bones panel again and turn it off here. And then you can see it's, let me center on that and zoom in. You can see it's now back to a dashed line. I'm going to hit R again to reactivate it. I'm going to show you the other method of turning it off without going into the panel. And that is, I'm going to go to the keyboard, hold down the Control key, and then hit R again. And that'll deactivate. So R rests the bone, and Control R unrests it, or deactivates it. I'm going to add a child bone to this bone by going to the Bones option and saying Add Child Bone. And it, of course, pops in. I'm going to take center off, so it'll quit moving around. It, of course, comes in at the end of the bone. And once again, I want to sort of drag that back down here. Now, because the bones are upside down and backwards, it may be a little awkward moving it around. And this is because it's using a totally different orientation from what we're used to. Once it's kind of placed next to there, I need to go into my top view and move it over. Before I do that, I'm going to finish rotating it on its pitch, so it's going to be placed along this whole entire trigger that we can see behind the bottle. I may need to move that over just a little bit. And you can see here, I'm moving on the Y. You'd expect it to be able to move up and down. But instead, it's moving this direction. That's because to the bone, that is the Y-axis, because I've flipped them all around and they're parented to other bones, which are also rotated. This can be kind of disconcerting at first. But you can see, by isolating channels, it becomes much easier to see which direction things are moving. So now that I have this about the right position, I'm going to change its rest length. And you can see it grows out from its pivot point. So I'm going to move that back in just a little bit. Once again, that was the Y that was moving that up and down that direction. And now I'll go to the top view and slide this bone over. And that is the X-axis. And once again back to the side view, and I can turn off the X because I don't want to move it in the X anymore. And I'm going to complete the rotation to make sure it is just right around the trigger. Now I'm going to activate the bone by hitting R on the keyboard again. And I'm going to reactivate its parent bone in the original chain. I'm going to select the trigger bone again. I'll hit P on the keyboard to bring up the bone panel. And now is when I'm going to activate limited range that we talked about before. I'm going to give this a minimum range and maximum range that are identical, so it's a solid area of influence. I'm not sure exactly how big to make this, so I'm going to start by making it about 200 millimeters in both the minimum and maximum, and now that the bone is active, we can see the area of influence. 200 was a bit large. I could probably shrink that down at least by half, so I'll hit P again and enter 100 millimeters in both and see how that looks. That's a little better. I want to make sure it encompasses it in the top view as well, and it does. And now I need to move this back over in the x-axis now that it's activated. That will drag the whole entire trigger back into the center of the bottle. So I'll go to Move and move it along the X because that's the direction I moved it in Modeler. You can see here that my limited range missed one of the points on the trigger. It was probably this bottom one right here. It was just outside of our limited range. So I'm going to undo the move so it moves back where it was in the Y or the X position. I'll hit P on the keyboard again, and I'll boost this up to about 120, and that's probably going to be just enough, to grab that little point. I need to make sure I hit Enter to accept that number in. That's probably just big enough to grab it. Let's try moving that bone back over again. Yep, there we go. Now we're moving all the points. Now by just dragging it in the top view along the X, it should stay perfectly positioned as it was before, but just moved all the way over to the side. Let's look in the perspective view and rotate that around. And we'll turn on our OpenGL again. And yes, you can see that the trigger is coming back out of the front of the spray bottle where it should. Now let's see what happens when we rotate this bone. Remember before it was deforming some of this mesh, and I believe it was that was the heading before, but we've rotated our bottle. His bottle was set up with the heading. Ours is the pitch, like we'd expect it to be. So now by animating this bone on the pitch, you can see it's not touching any of the rest of the mesh. That's because its rest position was far away and not touching or containing any of the points from the rest of the spray bottle. Yet, because this bone is parented to the other bones, if we go back to Objects and grab our goal and animate the bottle, you can see that the trigger moves with the rest of the bottle. So it animates alongside the rest of the bones. So this is a way of attaching a separate object. Take another example. Maybe you have a character wearing a hat, and you don't want the hat to deform with the rest of the body. You want his head to be able to move, but you don't want the hat to squish. You could move the hat up in the Y and pull it back down with a limited region bone to put it back on the character's head. This is also useful for things like eyeballs. Maybe you want bones in the whole entire character's face so he can move and squish, but you don't want the eyeballs to deform. You want them perfectly round, and you also want to be able to animate them maybe with IK, so you can move the eyeballs out, move them back in with limited region bones, which you could then animate. Next, we're going to take a look at the Object Replacement plugin. This is a different sort of a way of animating. It's a totally different mindset. If we take a look at a piece of animation from the Bug-Off commercial, this is from the kitchen destruction sequence, as we call it, and here you can see bullets ripping through the cabinet door. This effect was accomplished with the Object Replacement plugin, and that's what we're going to take a look at right now. If you see here, I have a total of 4 doors. One undamaged, one with 1 bullet hole, 2 bullet holes, and 3 bullet holes. We couldn't use morph targets for this because these all contain different point counts and point numbers. This is where object replacement comes in. The other thing to remember is that they're going to snap in one at a time, just like they did on the animation. Now we did add a few sparks or a few pieces of objects or particles blowing out of the holes to look like debris. But in general, to set this up, you need 4 doors. They don't need to be all loaded in. I just did this so that you could see what each of the doors look like next to each other. So I'm going to start by removing these doors. I'll hit the minus key on the keyboard to clear the object from the scene, and I'll do that for the 3 doors with holes. This door I'm going to bring back to the center, and I'm going to pull my camera in a little closer so we can see it just a little bit better. There we go. That should be fine. I'm going to go to the Objects panel, and I can do that by hitting P or by hitting the button at the top. I have the door selected. This is door 000. The other 3 doors are named similarly, yet the numbers change. This is, in effect, how the object replacement plugin works. 000 is referring to a frame number. This will be the door that's loaded in at the very beginning of the scene. The object replacement plugin, which can be found right here, is object sequence. We're going to load object sequence in, and what this tells us automatically, without changing a thing, is that in the same directory where this door was found, you'll also find another door with a different number. Just like loading an image sequence, as they progress, they'll be loaded into the scene. So if we had a door 001, it would load in at frame 1. If we had a door 002, it would load in at frame 2, and so on and so on. If we go back and look at our doors, you'll see that we have a door 000, which is the one currently loaded into layout, a door 005, 010, and 015. These are referring to frame numbers again. What this means is that when it gets to frame 5, the object replacement plugin tells it to load frame 5 or door 5. This door can be animated. It could be opening or closing, rotating, pivoting, whatever we want to do with it. It's not going to matter. Wherever it is in the animation and whatever's happening to it is going to happen to the sequentially loaded doors, much like an image sequence. If it's mapped on something, it's just going to keep loading new images no matter what's happening to the image or the object that it's on. I'm going to angle my camera a little bit over here so we can get a better view of this. And now you can see at 0 we have our plain door, and I'm going to move over to frame 5, and something you're going to notice, it didn't change. That's because the object replacement plugin doesn't realize that anything's happened. I either have to render the frame or make a preview. As soon as I do that, it knows to replace the objects. And you can see at frame 5, this one pops in, at frame 10, this hole pops in, and at frame 15, this hole pops in. It happens very quickly. I don't have to do anything else to it. So that's a simple use of object replacement to create a quite stunning effect. The techniques we've used on this tape are going to give you a good idea of the capabilities of Lightwave's animation tools. And don't forget that many of these techniques can be combined to add subtleties or secondary animation to your scenes and characters. Thanks for watching. I'm Ace Miles. Goodbye.